At Bridger Photonics, we get a lot of questions about how detection sensitivity relates to emissions reduction. So we put together this short video to help explain the relationship. Here we show emissions data captured by gas mapping LiDAR from over 12,000 production facilities in 5 major North American oil and gas basins, including the Alberta, Anadarko, Bakken, DJ, and Permian basins, shown in no particular order on this plot. Each data point on the plot represents one emitter, or leak. The y-axis shows the percent of aggregate emissions detected above a given emission rate, while the emission rate, typically in a logarithmic scale, is shown on the x-axis. Moving from left to right moves from large emission rates to small emission rates. To figure out what percentage of emissions would be detected by a given detection sensitivity, we simply find that sensitivity on the x-axis, go up until we reach the basin distribution of choice, and then go left until we reach the percentage on the y-axis. First, note that Bridger's stated detection sensitivity for the production sector, represented by this black line, is 3 kilograms an hour with greater than 90% probability of detection under typical conditions. So we have high confidence that a negligible number of leaks larger than this value or to the left of the black line were missed. Now for smaller leaks than this, or to the right of the black line, the chances of detecting leaks with gas mapping LiDAR goes down. While this plot does show that gas mapping LiDAR detected production sector leaks all the way down around 0.1 kilograms an hour, the probability of such a leak detection is extremely low. The roll-off behavior in this region of the emissions distribution isn't because leaks of that size don't exist. It's because detecting leaks below our stated sensitivity becomes less likely. Emissions distributions like this only show what is measured by a sensor technology, in this case, gas mapping LiDAR. So this plot really shows what percentage of emissions detected by gas mapping LiDAR would have been found if a less sensitive detector were used. Now let's look at a couple examples. The EPA's proposed rule suggests a sensitivity of 10 kilograms an hour. If we apply this sensitivity to these distributions, we can easily see that we would have detected between 59 and 82% of the emissions found by gas mapping LiDAR, depending on the basin. With the EPA's goal of reducing methane emissions by 75% compared to current values, this seems pretty reasonable. But what if we used a detection sensitivity of 50 kilograms an hour? Well, at this rate, only between 18 and 50% of the emissions from the 12,000 sites in our study would have been caught, making it impossible to reach the 75% reduction goal. At this point, it may be natural to ask, why not just detect 100% of emissions? Well, Bridger has worked closely with the oil and gas industry to identify a methane detection sensitivity that balances two important factors. First, the ability to detect the vast majority of methane emissions in production basins, and second, to enable efficient, impactful, and cost-effective repairs. With broad input from the production sector, Bridger operates gas mapping LiDAR at a detection sensitivity of 3 kilograms an hour with more than 90% probability of detection, achievable under typical conditions. We can certainly go more sensitive, but this sensitivity would bury our production sector clients with repairs that don't appreciably impact emissions. 3 kilograms an hour with greater than 90% probability of detection for the production sector detects more than 90% of basin-wide emissions while focusing operator time and resources repairing leaks that can significantly impact emissions reduction. In summary, detection sensitivity matters a great deal for emissions reduction. To reach the EPA's goal of significant reduction, we support the proposed detection sensitivity of 10 kilograms an hour with greater than 50% probability of detection in typical conditions. If you have any questions or want to find out more about gas mapping LiDAR, please contact Bridger Photonics and we'd be happy to help you out.